What's up, guys? Welcome back to LeetCode Path to Pro. Today is Monday, March 25th. Hope you all are doing well. Having a good start to the week. I'll turn this down a little bit, but yeah, I think today go over the contest from last week, this weekend. Yeah. Okay, let's do it. Oh, nice. Weekly contest 390. Oh, we can put it down here, yeah. Yeah, I didn't do as well as I wanted, but it's all good. Getting better. That's the most important thing. So, alright, let's go back to the first problem. This is a string problem. Excuse me. So we're given the first problem, it's 390, 30, 30, 90. We're given the maximum length substring of two occurrences. So we're given a string S, return the maximum length of a substring such that it contains the most two occurrences of each character. Yeah, so what I did, used a hash map length to just keep track of our max substring length, and then a pointer, just loop through, if that character is in our count plus equals 1, else equals 1, if that character that we just added causes our kind of window to have more than 2 of that character, we'll say while at count, we're going to decrement that, S of L, or add it, and then just take the length, max length. Yeah. So it works, I think, because this is O of n squared, or apparently not. It's pretty fast. Well, actually, okay. Oh, never mind. I did do it optimally. How did that O of n? What is this O of n? Excuse me. Guess that makes sense, yeah. Okay, so this is O of n. O of n, it's about time and space. And that's optimal. Pretty sweet. Pretty sweet. Honestly, for an easy, definitely not like the hardest easy, but on the harder side, let's say. you're combining a few concepts. Sliding window, hash maps, yeah, max function. So it's not crazy. But yeah. And now if you guys watch that video, this next problem is the one that gave me some trouble. I ended up getting it, but it took me forever. I think we did it in this. Hash map. Window. Snag this. Okay. Next problem. So this problem gave me some trouble. As you can see, though, it's very simple. So I was trying to do this crazy DFS. So you want to see my DFS?
Take first search.
It's pretty straightforward, but
What's the question?
so it's given an integer k. Initially, you have an array nums just 1.
Yeah.
On each turn, you can either increase any element in the array by 1, or you can essentially like duplicate an element in the array, and then you which are the minimum number of operations required to make the 7 elements in the final array. So.
It's always gonna start with 1.
Yeah.
I mean, so the strategy should probably be to like.
There's an O of 1 solution.
One solution.
So So I'll show you. I was doing like this shit. So like DFS, we were trying to cache it. Right, where I have this DFS function, I'm passing in n, which is the list.
Yeah.
Like the number of moves in our cache. And I'm taking the n sum, saying if n sum, if we've gotten to this point in less moves, then we just stop the iteration for that path.
Makes sense.
And then this is to do like both paths. Like we either, add one or. But it's too slow.
I mean, this is like basically a DP solution, actually.
This is faster. This is O of n, and this is faster, and it works.
Wait, let me see. Moves to the range and IK plus new moves equal math k over I.
Because essentially, the idea is like it's always optimal. If you work through something by hand, it's always optimal to add 1 to the start and then start duplicating.
Yeah.
It's always optimal to do that. So this solution, you just loop through. Basically, this is like looping through all the additions of 1 you could make.
And then
you just say, the new moves are, and then once you get to like essentially a new array that's like some I value, right, that you're looping through.
That makes total sense. I don't understand the -2 though.
Times. I think it's because we start at 1, and then.
Math's okay, so like for 11, it'll be 11 over 1.
It's like off 1 or whatever. Yeah, I don't know.
Interesting. Okay, so it's just like offset basically.
Yeah, you just have to offset it. Okay. But that's
a fucking genius solution.
Dude, I mean, I had to look at the hints. But the hints basically tell you to do this.
Right.
But then there's fucking O of 1 solutions.
Yeah, that's crazy.
Yeah.
I mean,
look at this.
It does make sense. But what if there is a strategy like... Okay, so is it like... Can I see the question statement again? Choose any element in the array and increase. What if like it's like, okay, add 1 to like that 1 itself, right, to make it 2, and then duplicate it, and then add another.
See, like, that's the thing though. It's never optimal to do that.
Because that's where like I would fucking get lost.
I know. I was like at first. I was like when I started just working through problems,
Right.
and I was like, I think there's like. I was like, I think there's just a math formula for this.
Right.
And I started doing it, and then I was like, I couldn't get it, and I was like, oh, never mind. Let's do DP. Like, let's just go.
Okay.
Like minimum, like we're looking for the minimum thing. I'm like, it's gonna be DP.
Yeah.
But
11 plus 1, 12, 10. So, interesting. I was just thinking.
I mean, there's
offset.
multiple optimal ways to get to a solution sometimes, but always one of the optimal solutions is just adding one and then duplicating that once you get to a certain value.
Duplicating it. Okay, so basically, like the strategy is like with the first, like the very, like the original term, you just want to do all the addition operations to that,
and then you just start duplicating.
Because that's what I'm saying. Like, I feel like it would be a hard if the optimal strategy lied like somewhere like in between, where it's like, oh, you add 2 to like this one to make it 3, duplicate it 4 times, and then like.
Well, that's where this solution would work.
Yeah,
if it was a hard, because they probably wouldn't have as strict of time limit.
Yeah.
Okay,
so then it probably wouldn't even be a hard, I guess.
This would work for that, I think, right? Because you're gonna run into situations where you've added some, and then you've.
Yeah.
Right. This is just.
What is N? Is N like a list?
N is this. It's just the initial starting list.
Let me see what operations you do after the scene, like the caching it. N1, then copy.
These are just to create copies so that I can perform the 2 operations.
Let's see, like even you are not going for that though. Like with the thing I'm talking about, which is like you're like
it'll get mixed up, right?
What?
Won't it get mixed up?
Oh, you're right. Yeah. I mean that is true.
The recursive calls will start getting mixed, right? Or will they not?
No, they will get mixed up. I was thinking about more like where you said like the optimal strategy doesn't lie, which is like doing it multiple times over and then like adding +1 to like one of the random elements and then like replicating that. But I feel like if you're going for like, because I think the pattern like lies in the exponential growth that the duplication allows is like because it's like if you just start off with 1 like 3 times 1 is gonna be just fucking 3, but like 3 times 3 is gonna be 9, which is like just gonna grow much faster.
Yeah. Yeah, I want to see the O one time.
Nice.
Wait, is this the same exact code as mine? No, not quite.
I feel so rusty at Beatco right now.
You'll get it back so
I
fast.
haven't done anything in like 3 weeks.
So you take the square root of K. So this works. You'll get it back so fast. Oh. That's crazy, bro. int. Okay. That comes faster than this. Crazy. Some math. What is this? Do I have math? Oh, excuse me. Yeah, that's pretty sweet math. Excuse me. It's like the same line of code. Or similar. Oops, did not mean to do that. Alright, here we go on the first actual problem. Right, because I didn't get to this one. Because that last one took me so damn long. Alright. If two integer arrays, nums of frequency of equal length n. Frequency. Is high. So frequency. Oh, the count. Okay. I just did a hash map, yeah? If I feel like I'm not thinking this correctly because this is easy, right? So if nums of I in count, oh, because then we have to sort it. Oh, that's pretty slow. We have to sort it each time. Actually, if I can do this. If nums of I in count, count of I plus equals frequency of I, if count of I greater than most frequent, most frequent equals count of I. Most frig, else nums of I equals 1 plus so okay. The collection is empty. Oh, that's where the issue is, yeah. Yeah, that's gonna be an issue. Let's try sorting. I think it'll be too slow though. Yeah, nums I equals 1 plus frequency of I minus 1. And at the end here, we sort. How do you sort? Just Okay. So the last one. Is there a way we could avoid sorting actually? So if we do this, there's a sorted count. Right. Oops. Yeah. We also have my frequency. Set here. We want the late one, 2, or 1, like that. Okay. What if we make max frequency a list? Okay. And we say if count I greater than max frequency of 1, then we check max frequency of 0 is going to equal I. Max frequency of 1 equals count of I. Okay. If count of I, or sorry, if I equals frequency actually we can do that down here, yeah? No sort is true. Do a boolean. if no sort let's do sort makes more sense. If and count by less than equal to 0, reset this. Oh, that's not gonna be a situation. Let's situation where we sort. Here, so to speak, frequency of 1. Excuse me. 1. So this 0 is going to be sorted count of big 1 of 0. And we just answer right here. Max frequency. What? Oh, that's because it's knows why. Three. Oh, that's what. Yeah. It's not counted by. It's knows by. Right. It's like I shouldn't flirt. He's a little scared. I think he's gonna time it. Oh, See, I don't know if we've quite hit the time limit. Excluding cases. Okay. What's going on? ellipses as we go through this. So 2, 4, 2. I don't know, see, it should be 2's thing. 5. Okay. That's our issue. So if those lines count, it's greater than max frequency. Ah, that's the problem. Okay, so then we subtracted 2 because we have no way to keep track of the previous. Oh, because we have to set sort to equal to true. Oh. Now it's work. Yeah. I think it's gonna be time to it. Yeah, it is. Damn. Sorting's so expensive. Yeah, yeah. Look at this beast. If we take out the sort, do we get past the guy? Yeah, we do. Interesting. So I mean, it almost works. Yeah, damn. That's pretty cool though. I mean, this works. It's just slow. Very slow. Yeah, I guess the answer would be instead of using this and sorting, we just do it. This is a 6 solution. So, oh god. Yep. Guess it just cuts off Vicky. Set. Okay. So, okay, that's pretty cool. Count of I plus equals F. Okay. Yep. Heat push. Another heat. Count. Fully understand that. The while loop is tough. So while count. Let's print out our heap. That might help. So heap 4-2. So while count of H 0 of 1 does not equal, what is this? Whole. What would the 0, 0, 20 be here? What does that pull up? Actually, we can check. I think this would be a good way. Let me just do it like this. It's still run. Yes. Okay, so H00 is this guy. So while count of H of 1. Heaped up pop. Heap pop. What is the point? What is a while loop? The recurrent efficacy. It means if the frequency. Oh, because this is count. So while count. Oh. Oh, okay, yeah, that's pretty simple. So this is just checking. Oh, Jesus. Brutal. Yeah. Okay, cool. Yeah, the solution's sick. Very nice. Very nice. Very nice solution, sir. What's the time complexity of that? Algorithm. Algorithm. Space. Oh, lucky. Okay. And this is a hash map. And yeah. I like this. It's a little more formative. Not right what we're really doing. Because in Python you can only have, I think, what, min heaps. So this is the way to make a max heap. Just make sure that still works. To make any crazy errors. Okay, cool. Let's add this one. School problem. This is what, array? Yeah. Cool. Cool. Yeah, SQL problem. I'm curious if we can get this to work. I hope, because this is going to sort even if. Fingernail. What if we do this?
Alright, bro.
You going to bed?
Yeah. Just one more day, I feel like. I don't think trouble's up.
Nice. Nice. Zero. Set previous.
Problem is this.
This is the problem. You can solve like the correct solution
Right.
is to do something like this. You have like a heap and a hash map, and it's pretty straightforward. It's not that straightforward. It's kind of confusing, but it's
Like a heap in a hash map?
no. You have a heap and then a hash map separate. And you just use those. But I was trying to do it with just the hash map, and then I sort the hash map. But that's inside of for loop, so it's very expensive. But
Yes.
I'm trying to, mitigate the amount of times. You don't need to sort it every time you loop. So I'm seeing if I can get it because I got time
You
limit.
just want to sort it one time, right?
No, you might have to sort it more times.
Oh,
But there's
you
only-
gotta keep sorting.
You don't have to sort it every time though.
But you have to probably sort multiple times.
Yeah, I mean it depends on what you're given, but I'm
I
trying.
feel like heap is definitely the thing for that, right?
It's better, but I'm just trying. This is what I came up with. I'm just trying to see if I can get it to work because I got the time limit. But
And this is a third problem.
yeah, this was the third.
Third problems usually also have like hidden solutions. You know, like hidden questions. I don't know if you've seen that.
What do you mean? Oh, at the bottom.
The only weekly I did, like the third problem was basically the same as the first problem,
Yeah.
but had like hidden questions. So like you can't even see what the issue is with the code because the question, like the example itself, is hidden.
Oh yeah. I see what you're saying. Yeah.
It's like retarded.
That's not previous. Max frequency 0. We check if we don't need to sort, right? Nah, it's still too slow. I bet just sorting like one time. Does this even work? Oh.
Worked?
Oh, wait. This is why. Because this isn't doing anything. Previous. So we want to sort the first. So let's set this to float. Now that should work. Yeah. What? Print previous. Two, two, three. Okay, we're setting it down here. Set it up there. That doesn't work either. So I guess we only want to set it if we sort it, right? If we did insert.
Alright, bro. So good night.
Alright, I thought.
See you in the morning.
Sleep on,
Unless
yeah.
you
I'll
leave
see
for
you in
work
the
earlier
morning.
than me.
No. Right. That should.
Alright,
Good night, bro. That should run up too. So that should go off. Yeah. This isn't gonna work either. It doesn't work sometimes. So I don't think this. So I think this is assuming that we can't go to 0. Yeah, it's just garbage. Okay, well, yeah, we tried. Cool. See what there it is. No, thanks. I'll pass for today. One day. Alright, cool. Yeah, thanks for watching, guys. See you later.